Good morning, everyone. Today I want to talk a little bit about VPNs. They're an extremely powerful tool for setting up a network so that it does what you want and making sure that that network is secure, but they're kind of misunderstood. So I want to talk about what a VPN is, why you might want one, and when it's the appropriate tool to solve the problem that you have.
When I talk about a VPN, you might think of a commercial VPN like this one or this one. But before we can get to talking about commercial VPNs and what they make sense for, I want to take some time talking about what VPNs are in general and what they were designed for.
VPN stands for Virtual Private Network. Now, let's go ahead and start at the bottom. A network is a collection of computers that are hooked together so that software on the computers can talk to each other. So frequently we'll draw that something like this. We have some computers. In this case, we have 3 of them, and the 3 computers are somehow connected together so that if we have software running on computer A, and that software wants to send a message to computer B or computer C, it can go ahead and do that. When we think about networks, most commonly we think about the biggest one, the internet. But really, the internet is built as a collection of a bunch of smaller networks, and we can see that in the name. It's the internet, or a network of networks. So the internet is a bunch of networks connected together. Maybe we have the Coca-Cola network over here with a bunch of computers hooked together somehow. Some servers they have on site, some workstations they have for sales or whatever. And that's connected off to some stuff in the middle here, which traditionally has been drawn as a cloud. That's a bad cloud. Then we have home networks over here, someone's house, and then the internet also connects, the US Department of Defense, and they have a bunch of computers connected over here, all together in some network. And so we have multiple little networks connected together into the global internet. Now, the most common way that these networks are set up connected to the internet is the way I have it drawn for most of these groups here. For example, Corporation A up here, I'm showing 4 machines, but one of the machines is sort of on the edge between the internet and the other computers here. And we're going to go ahead and call that a router. And so when messages come from the internet to Corp A's network, those messages are going to go through the router before they get to any other machines on that network. Now, we could have 2 layers here, like I show over here, where we have a router that's directly connected to the internet, and then it's connected to some other routers here that are then connected to other little pieces of the network. And really, we could call every router as being the core of a local network, although that's probably simplifying so much that it's not really useful. But one thing that is worth distinguishing here is the concept of public versus private networks on the internet. When we're talking about the internet, that means that we are usually talking about the Internet Protocol IP, and the Internet Protocol defines a standard for how we're going to give addresses to machines on networks in general, and machines on the internet, although there are networks that use the Internet Protocol that are not connected to the internet. Even for networks that are connected to the internet, it's meaningful to distinguish between public networks and private networks. And the difference is whether the machines on that network are assigned public internet addresses or private internet addresses. Now, in the old version of Internet Protocol, Internet version 4, IPv4, Internet Protocol version 4, addresses look like 4 numbers, maybe something like 93.16.181.25. So there's 4 numbers separated by dots, and each one of these numbers is in the range 0 to 255 because it is 1 byte of data, or 1 8-bit number. So that's the range that we can store in 1 byte. And so an IPv4 address is 4 bytes, one for each number between the dots. But in the structure of these addresses, some particular ranges of addresses were reserved for private network. In Internet Protocol version 4, there are 3 different ranges of addresses that are used as private addresses. Those addresses are 10. The first number in the address is 10, and then the other 3 numbers are anything. 192.168, and then anything, or 172, and then any number 16 through 31, and then the last 2 numbers can be anything. So these are the private addresses in IPv4. And most of the other possible addresses that we can build with 4 numbers separated by dots here are going to be public addresses in IPv4. Now, the point of private addresses is that any network administrator can just use addresses in these ranges for their private network without worrying about whether other people elsewhere in the world are also using those addresses. If you say that your network is going to use the 192.168 addresses, then you have space for 256 times 256 is about 64,000 computers on your local network that can communicate with each other with those addresses without worrying about the rest of the world. If you do that, you've built a private network. The alternative to a private network is to assign all the machines on your network public internet addresses. And to do that, you have to make sure that you have unique public addresses. So you're going to have to request for some addresses to be assigned to you by the Internet Assigned Numbers Authority, the IANA. Now, the IANA is the Global Internet Number Authority. So if you're actually going to do it, you'll probably go to your local number authority. There's one for each continent approximately. But you have to have an authority assign you a range of addresses so that you have unique addresses. And if you want arbitrary computers on the internet to be able to send you messages to your computers, then those computers that are going to receive messages need public internet addresses. But conveniently, if you want to have the computers on your network send messages to other computers and even get responses, you don't necessarily need public addresses. If you have private addresses on your network, let's go ahead and say that Corporation D here assigns all their computers addresses out of the 172.16.5, and then this last digit is 7, 8, 9, and 10. In that case, this machine's address is going to be 172.16.5.9. So that machine has a private address. It is on a private network. But if it wants to send a message over to, say, this machine over here, which has a public address, because Corporation A is going to have a public network. So this is going to be, let's go with 50.50.50.876. So this is 50.50.50.8. So this machine here can send a message to 50.50.50.8, and it will go over to this router. And that router is going to do something called network address translation, or NAT, to change the message being sent by this computer so it looks like this computer is the source. And so this computer here is going to have a public address. So maybe that's 118.10.19.20, just arbitrarily. And so when this machine sends a message to this machine, it goes through the NAT router. The NAT router rewrites that message, so the return address is 118.10.19.20. It gets routed through the internet to this machine. This machine responds to the return address, which sends that response back to the NAT router. The NAT router then rewrites that response so that it passes on to the original source. And to do that, the NAT router has to remember all of the messages that it recently rewrote so it can identify responses and get them back to where they're supposed to go. But the result of this is that whether your network is set up as a private network like Corp D here, or a public network like Corp A, you can still access most internet services like websites on the web or email or most of the other standard services that are commonly used today, whether the local network is assigning individual computers private addresses or public addresses. The big complication comes if this machine over here wants to send a message to this machine over here that isn't a response, and in that case, it's just not possible. Because this machine over here doesn't have a public internet address, there's no way for this machine to send a message to that other machine. The only way that machines with private addresses can participate in the internet is by being the initiator of a message and sending those messages through a NAT router, which will do the rerouting and remembering of sessions to allow the responses to come back. Now, on your local home network, almost certainly the devices that you have private addresses. Home networks are private networks unless you paid extra money to your ISP to be assigned additional public IP addresses. And the most common address range that gets assigned is out of the 192.168 block. So we have a router here. That router has a public address. Let's call it 118.10.19.21. It very well might be the next address immediately after this company's address. This means that these two have the same internet service provider. That's fine. But on this home network, the two machines are likely to be assigned the addresses 192.168.1.101 and then 192.168.1.102. 101 and 102. That's the most likely most likely home network addresses. After the 192.168.1 block, the next most common block that gets used for home routers is 192.168.100. Whatever. So when you, from a home network with a home router, are accessing the internet, your home router is doing network address translation to make it so that you can send packets outward, and then the responses can be translated correctly to go back to the machine that initiated the session. Now, if you really want to set things up so that your local machine can host some sort of service that other machines on the internet can send messages to, like if you want to run your own web server, you actually still can do it in this sort of home network setup. What you need to do is tell your router to do port forwarding. So if you want to run an unencrypted website, you're going to say that you want to forward port 80. So requests coming in to 118.10.19.21 port 80 will get forwarded by this router onto some other machine, and then if there's a web server running on this local machine, it can go ahead and respond. The translation will happen then sort of in the other direction so that the response to that web request can get sent back to whoever requested it. So when we're talking about internet protocol and internet protocol addresses, one thing that's pretty easy to notice here is that 256 times 256 times 256 times 256 isn't that big a number. It's about 4 billion. And so there are only 4 billion possible public internet addresses, give or take. And there's more than 4 billion people in the world, and at least I as a person tend to use more than one public IP address at a time. And therefore, there aren't actually enough addresses in Internet Protocol version 4. Now, you can do a little bit with putting things behind NAT routers to try to fix that, but that also breaks some stuff, so it's not an excellent long-term solution. The solution that people came up with was something called Internet Protocol version 6, which instead of having 32-bit addresses has 128-bit addresses, kind of. But in any case, IPv6 has longer addresses, and so allows more computers to be to have public addresses at the same time. It has much bigger addresses and therefore drastically more available addresses. And so as we move to IPv6, which is happening slowly, has been happening slowly for a while, the limitation of addresses will go away. And actually some of the complications with networking with private networks go away, because with the number of addresses we have with IPv6, there isn't a reason to use private addresses just to save addresses. The only reason to use private addresses under IPv6 is if you really intend to have a network that you've designed to have limited connectivity to the outside world. In IPv4, private networks are very common because public addresses are, there aren't enough of them, and therefore using private networks and network address translation saves addresses and money. With that, we can now go on to talk a little bit about how the private part of virtual private networks fits into this story. All right, so before we get into a virtual private network, let me go ahead and talk a little bit about a typical private network being used to its fullest. So here we have an office. And at this office, we have 2 desks with desktop computers on them. This is one desk, and it has a computer with the address 10.10.10.101. Our second desk has a computer on it with the address 10.10.10.102. Now, addresses starting with a 10 are private addresses, so this is a private network. And you'll note that I haven't even bothered drawing in a connection to the internet because we don't need it for this example. The one other thing that matters on this network is we have an email server. And that email server has an address of 10.10.10.201. And so if people in this office want to check their email, that is a entirely local thing that happens within the local area network, or the private network here. The computer on this desk, the email client, can send a message. It'll go through the router, it'll get to the email server. The email server will send a response back through the router, and the email client here will find out if this user has any emails. Same for the other user. This sort of setup of having servers locally on the private network has a couple of advantages, but one really obvious one is a security advantage. We can set it up so that this email server only accepts requests from the private network. So then even as we go ahead and connect our network out to the public internet here, we don't really have to worry about requests from people in the public internet who aren't supposed to be able to access our email server going to the email server, because we can tell the email server that it should only accept requests coming from people on the 10.10.10 private network. And we can even tell the router that it shouldn't pass requests to the email server unless they're coming from the 10.10.10 private network. If you're not in the office, you don't need to talk to the email server. And that's great and all until, I don't know, everybody decides that they're going to be working from their home offices for 2 years suddenly. And at that point, we're going to have someone over here on their home network with their router connected to their company laptop. And they'll be off on a private network over here at 192.168.1.101. And suddenly, when they try to check their email, well, the first problem here is that they can't even express where the server is over here, because this server is on a private network that's a different private network from this server, or from this laptop, and therefore there's no address that we can use over here that will cause packets to get routed through the internet over here. The internet will not route packets to private addresses at all. Private addresses only get routed over local private networks. So if we want to allow this user at home to connect to this email server at the office, probably the most straightforward way to do that is to just give the email server a public internet address. We can have the router handle having some people have local addresses, local private addresses, and then have 1 or 2 things with like port forwards or multiple virtual local networks. There's a whole bunch of ways to handle that from a networking perspective, but the simplest solution is just to give this a public address, and then the home user can connect to the public address and everything will work great. And that's probably the right solution in this case. But if there are a bunch of other services on the Office network, and some of those services really weren't designed to be exposed to the public network, then giving them all public addresses is an awful lot of work and can lead to security problems if the administrators miss anything. So another solution here is that we can go ahead and add a virtual private network. And the most straightforward way to do that is to add another server here, which is going to be the VPN server. And I'm going to go ahead and give it an address on this local network. It's going to get a private address. But we're also going to give this machine a public address. So it's going to have an additional address. It's going to be, I don't know, 20.20.20.20. And so this machine is now accessible from the public internet. And we're going to mark this as being a virtual router. It's a VPN server, but the role that a VPN server plays is being a virtual router. And so then we're going to put, in the simplest version of this, we're going to go ahead and make an encrypted tunnel through the internet over to this machine on the home network, and we're going to give it a additional address as well. Now, this is where this gets slightly tricky, because we have to figure out whether we're going to extend this private network over here through this encrypted tunnel, or whether we're going to add a second network. And in this particular case, the simplest solution is going to be probably just to extend this local private network through the tunnel over here. So this machine now has a private address on the local network, but it's also going to have a private address on the office network, just like it was physically over at the office. So we'll go ahead and give it 10.10.10.151. And so now this machine is on the private network over here through this encrypted tunnel, this virtual private network encrypted tunnel. And that means that we can go ahead and connect directly to the email server with its private address without sending like unencrypted traffic over the public internet, because that traffic on the that traffic for the private network is going to go through the tunnel provided by the virtual private network software. And that solves our sort of network infrastructure problem here. So VPN software gives us a virtual private network by creating encrypted tunnels through the public internet. All right, here we have a network set up for a company where most of the people work from home, but there are one or two people who work at the office, and there are servers at the office. So the setup that we have here, we want to be able to have everybody access this file server, regardless of where they are. And we don't want to just give the file server a public address, because we want the security benefit of making sure that only people who are on the private network have access. So what we've done is, over at a data center somewhere other than the office or any house, we've set up a VPN server. And that VPN server is going to have a public address, but all of these other machines are only going to have private addresses on private networks. And this is 3 separate private networks. So we have 2 homes, and we have the office. And it may be that these 3 machines, this desktop, this laptop, and this laptop, all have the same private IP address, so they couldn't possibly talk to each other, even if we tried to do routing. But what we can do is have the VPN just add a new private network. We could say that the 2 home networks are on 192.something. The office is on 10.something. And so we'll set up the VPN on like 172.16.something. And then we're going to use the VPN server to set up encrypted tunnels out to everyone, and every machine individually. We'll set up encrypted tunnels so that then we can give everybody 172.16 addresses. And now, no matter where these machines are in the world, even if this is a laptop here, and the person who normally works at this home network picks up this laptop, brings it to a hotel and connects to a hotel network, that laptop, because it's running VPN software, will always be able to connect to the public IP address of this VPN server at the data center, and then be able to connect to the virtual private network and access all these other machines on that private network. So that has a benefit in security, that has a benefit in having things work, being able to pick up a machine and bring it to another network like a hotel network and then have everything still work is sort of tricky without setting up a VPN. And that leads into sort of one of the biggest advantages of VPNs in this sort of situation, and that is just the simplicity of this setup. Once we've got the appropriate machines onto a VPN, they're going to just pretty much work everywhere, regardless of like what the individual local network setups are, unless the individual local network setups are actually broken. If they're actually like blocking VPN or traffic or something, then stuff will break. But as long as they're not broken, things will work. Another advantage to VPNs over just like giving the file server its own public IP address is that VPN authentication tends to be relatively strong. In order to connect to this VPN server, you're going to have usually at least a digital certificate with digital signatures. And that is a like much stronger authentication mechanism than anything involving passwords or any of that stuff. Even two-factor authentication with your phone is not as strong as just having a digital certificate with digital signatures. So most of my examples so far have been sort of business applications, because those are the obvious uses of a VPN. But let me give you an example of where I use a VPN right now on my home network. My wife has some snakes. And it's sort of important what temperature the snakes are. Snakes do not like being the wrong temperature. And so the snakes live in snake cages. And in the room next to the snake cage, I have a temperature sensor. And that temperature sensor is hooked up to a computer. And that computer Wi-Fi's out to a Wi-Fi router. And that Wi-Fi router is on my local network. In fact, that Wi-Fi router is hooked up to another router, which is then hooked up to the internet. So if I'm on the local network, and this temperature sensing computer has a web server on it, and if you connect to the web server, you can see what temperature the room with the snake in it is. So if I'm in the local network, I can just punch in the local address of the temperature sensor computer and see what temperature the room is. But if I'm not there, if I'm somewhere else off at some sort of public Wi-Fi, then this thing has a local address. And so there's no way to make a direct connection because it doesn't have a public address. And so the solution that I have to this is that off at a data center, I have a virtual server. And that virtual server is a VPN server. And so it has a VPN encrypted tunnel to that temperature sensor computer. And actually, this is also a web proxy. So if I am not at home, I can go ahead and send a web request to this virtual server at the data center, which has a public address. That will get routed through this encrypted tunnel to the temperature sensor, and I can see whether the snake is freezing. This sort of problem is another perfectly reasonable use for a VPN. So Snake, what do you think about VPNs? When do we need a VPN? The first thing that we need is we have programs running on two computers that want to communicate with each other. The second thing that we need is that for whatever reason, those programs would work perfectly if we were hooked up to the same LAN. LAN is local area network, and the sort of simplest version of that is two computers plugged into the same switch or plugged into the same router. So if we have two computers hooked up to the same LAN, Sometimes they can do things that they can't do otherwise, like be on the same local network and have the same local network addresses. But another good example is a printer. If you have a printer plugged into your home network, and then you try to print from your laptop that's connected to the same home network, the laptop can usually just find the printer if it's a network printer. Whereas if you're somewhere other than your home network and try to print to your home printer, it's not going to work because you're not on the same network, and so your laptop can't discover your printer. So if we have two computers, and a printer is a computer, that want to communicate, if they would work if they're both on the same LAN, but they're not on the same local area network. If these three conditions are true, then yeah, you definitely want a VPN. And the same is true if you can sort of create this problem. If you have two computers that want to communicate, and you could just like give them public network addresses, but you don't want to for security or simplicity reasons, and you can set up the two programs so that they would be able to communicate fine if they were on the same LAN by doing things like requiring a local address to connect, then using a VPN to make it so that it looks like they're on the same local area network is a perfectly reasonable use of a VPN. The most common time we hear about VPNs is for what I want to call commercial VPNs. And let's go ahead and just draw a diagram of how that works. So you're at home, you have your home router. You're going to go ahead and connect to a computer. Your home router is going to connect to the internet. And then let's say you want to access some website. So over here, we're just going to have a web server. So normally, if you want to go ahead and send a request to this web server, you'll send a message from your home computer. It will go through your local router, which will do network address translation. It'll get routed through the internet, go to the web server. The web server will respond by sending a message back to your router, which sends a message to your computer. And what a commercial VPN does is says that instead of being on your private network produced by your home router, they're going to go ahead and give you access to this VPN server. And this VPN server is going to create an encrypted tunnel through the internet from your personal machine to this VPN server run by the commercial VPN company. And so now and then you're going to send all your internet traffic through the tunnel. And so now instead of your request going through your home router to this web server you want to access, it goes through this VPN server, which acts as a replacement for your router, over to this web server that you want to access. So functionally, there's not really any difference. Instead of going through a home router that's going to do network address translation, it's going through this VPN server that's going to do network address translation. And the reason that commercial VPN providers give for wanting to do this is that it hides your IP address. So this home router is going to be assigned a public internet address by your ISP, and your ISP knows which IP address was assigned to which user at which time. And so if this web server is logging their traffic, and they are, web servers log their traffic, then this internet protocol address, which could conceptually be connected to you, is logged in their thing. And so you lose some privacy by letting the web server know your IP address. Right, so what the VPN server is going to do is hide that IP address, and most of these commercial VPN providers say that they don't keep logs. And so they're saying that the web server can no longer link that IP address specifically to you. And that might be a useful service in some cases. All right, so the first example of why that might be helpful is if this web server is the BBC with a new episode of, I don't know, some BBC television show that you want to watch. And the BBC decides that because you're not paying a television license in England, because you're not in England, they're not going to let you see their new TV show. And so what you'll do is access a VPN server in London. And so then when your request goes through the VPN server to the BBC BBC sees a source address in London, and you're able to have, by paying for a commercial VPN, you can spoof your location and bypass this sort of region locking for internet services. So that's a perfectly reasonable reason to pay for a commercial VPN, to sort of change where it looks like your traffic's coming from, and therefore be able to access content that the content provider didn't necessarily want to provide to you. All right, another possible reason is that this web server is streaming a movie that they don't have a copyright license for. And so if you were to connect directly to this web server, then your IP and their logs would be evidence that you had violated copyright law, which conceptually has relatively large penalties, and you don't want it to be so easy for the copyright holder to request the web logs from the server and then request the IP logs from your ISP, connect that pirate stream request to you, and then send you an angry letter asking for a lot of money. Now, unfortunately, commercial VPNs frequently either explicitly advertise their service or sort of implicitly imply their service is good for preventing surveillance from big tech companies. And by big tech companies, I'm talking about Google or Amazon or Facebook, etc. Microsoft, Apple. Having a commercial VPN service when you're connecting to these big tech companies does not provide you any significant privacy benefit. And the reason for that is actually pretty easy to see. Specifically, imagine for a moment that we're not talking about a home network over here. Instead, we're talking about a school network, maybe a college that you're going to. So if you connect to Google directly from your school network, then you probably have a private IP address on the school network. You're going through a router that's doing network address translation, and that router is going to have a public IP address, and that public IP address is going to be shared by tens or hundreds of students at the school. And so you have some level of anonymity in that IP address because it's shared by a bunch of people. That's the sort of core concept of anonymity in sort of networking, is that you can't be distinguished from other users. And so there's an anonymity set of people that you could be, and just the IP address isn't going to say which of the users at the school you are. So if you connect to Google from the school, they already have to deal with this problem of you being on a private network and you being part of a sort of medium-sized anonymity set. And so their entire system for tracking and profiling people just assumes that people are going to be connecting from these shared networks. The fact that you're going through a layer of network address translation with a shared network doesn't really matter to big tech companies. They expect that when they're profiling people. So by using a VPN, you're no longer part of this anonymity set of 100 students at your school. Instead, you're part of an anonymity set of 100 users of this VPN server at that time, etc. And so just using a VPN isn't really changing anything. Now, that being said, if you go ahead and connect to a VPN and then connect to Google, and you have a freshly installed browser with no stored data at all, no cookies, nothing, and you just make one request to Google search, then they won't immediately be able to identify who you are. That's a new user session from what appears to be a new user, and that happens to them relatively frequently. And so it's worth thinking about what they're going to do when they get a request like that. They could just say, I don't know who this came from, I'm going to throw it away. But every time a new user connects to their service at all, that's what the first request looks like. So that's something that they have to deal with in tracking any user. So what they're actually going to do is they're going to create a new user session for that one request, and they're going to start tracking it. All right. So when a big tech company like Google sees a request that they can't identify the user for, there's two possibilities. Either that user is really new, they've never seen them before, and in that case, that's great. They get to track someone they've never tracked before. Or this is from a user that they already know about, and they just haven't figured out who that is yet. And so what they're going to be doing is every time a new request comes in that they can link to that session, they're going to be trying to figure out if it can be linked back to any of the other sessions that they already have. Now, in fact, the model that these big tech companies actually use to keep track of users is almost certainly probabilistically linking individual user sessions together into user profiles. They're going to create a new session, they're going to record that session, and they're going to try to link it to other sessions. That's the plan every time. And so the profile that Google or Amazon or Apple has of you is just a collection of these sessions. So this raises the question of, if Google or any big tech company can't identify who you are on that first request from a clean browser on a newly first used commercial VPN, doesn't that mean that with a lot of work and operational security OPSEC practices, you could establish multiple profiles and keep them separate? And absolutely it does. If you put in enough effort, you can outsmart the systems trying to identify that those two profiles are the same person, and you can get Google to think that you are actually two different people. But all it takes is a couple hints for them to merge those profiles. For example, you could try to say you're going to have the VPN on. We're going to have the VPN, and we're going to have a browser. So VPN is going to be on for user A, and you're going to use Chrome. And then the VPN is going to be off when you're trying to be user B, and you're going to use Firefox. So Chrome and Firefox aren't going to share session cookies. You don't have to worry about that. They'll have different browser fingerprints. Because the VPN is on for user A and off for user B, they're going to have different public IP addresses. Initially, when you do this, you're going to look like two separate users to Google. All right, and we'll log into our Google account when we're on Chrome, and we will never log into our Google account when we're on Firefox. So this will work for a little while, and then you make one mistake, and you oopsie turn on your VPN when you're using Firefox, and now they have a session record of this user who they recognize having the same IP address as this user who they also recognize. And with that one oopsie of a shared IP address, that's probably not enough information for them to link you as the same user, but even then that depends. For example, I use desktop Linux as my main operating system. And so both of these browser fingerprints are going to show up as Linux. We'll have Chrome on Linux and Firefox on Linux. And so then we have to ask how many people on the VPN use Linux as their desktop operating system. And maybe the probability just from that one mistake is much smaller now because a lot of people aren't using Linux. Or maybe I make another mistake. Now, if I log in here once, I've lost the game. These profiles are merged. Google knows for sure that they're the same person. So there's a mistake I can't make. If I use the wrong browser, they're going to probably be able to link the session together. If I turn the VPN off for a user A action, then they'll almost certainly be able to link the sessions together because not that many people share my IP address. So it's possible to try to maintain multiple user profiles, but it's very difficult. And once we start to talk about multiple devices, it gets even more difficult because, again, sessions from multiple different devices are something that big tech companies are expecting, and they're trying to merge those profiles together. That's the whole point of their profiling system, is to identify which people are making which requests. All right, so to wrap up, what is a VPN for and why would you use one? Really, there's two distinct things here. We have a VPN that you set up or your network administrator sets up. And that's very different from a commercial VPN, where you buy access to a VPN server and then route all your traffic through it. So for your VPN, the reason that you would do this is to connect your devices together. If you want to communicate from one of your computers to another one of your computers or to a network of your computers, or if you want to connect an office in your organization to another office or to people working at home, that is what a normal use of VPN software does. And it does it very well, and it's an extremely powerful tool that's worth spending some time playing with if you do any network administration kind of stuff. On the other hand, a commercial VPN is really suitable for exactly one purpose, and that is spoofing your location so you can see television shows on Netflix that the copyright owner doesn't want you to watch. And with that, that's all I have to say about VPNs for right now. So thank you for watching this video. Make sure to click to the blog link below the video and subscribe to me via RSS so you don't miss anything, and have a wonderful rest of your day.